Hello everyone, we are from Atria Institute of Technology. Today we are going to explore an interesting concept from computer networks, that is the Hdlc protocol stimulation for synchronous serial communication. The goal of this project is to demonstrate how the Hdlc protocol works in a synchronous serial communication setup using a Cisco packet tracer. The Hdlc stands for High Level Data Link Protocol. It's a bit-oriented protocol used at data link layer of OSI model. This ensures reliable, synchronized, and error-free data transfer between two directly connected devices, such as routers in a WAN, that is wide area. Now let us look at the construction of the network in Cisco Packet Tracer. In this simulation, I have built a WAN setting up two routers and two end devices, that are PC0 and PC1. The connections are as follows. PC0 is connected to router 1 using a fast Ethernet cable. The router 1 is connected to router 2 using serial DCE or DTE cable. This is where HDLC communication takes place. The router 2 is connected to PC1 using another fast Ethernet cable. So the data path is PC0 to router 1 to serial D, HDLC link to router 2 to PC1. The IP configurations are as follows: the devices, interface, IP address, and nodes. The devices are PC0, router 1, and router 2, and PC1. The interfaces will be either fast Ethernet 0, fast Ethernet 0 or 0, serial 000, and IP address will be as follows. Now, the router configuration steps. On router 1, assigned IP address and clock rates are as DCE. On router 2, also the address has been slightly changed with the IP address. This establishes a complete end-to-end connection between the two networks. Understanding the Hdlc protocol. Before showing the demo, let's understand how Hdlc actually works. SDLC, or High Level Data Link Control, is a bit-oriented synchronous protocol used to control data flow and detect errors. It works over serial links where both sender and receiver shares a common clock signal for synchronization. Each data packet sent across the link is called frame, and it has a specific structure. The structure goes as flag, address, control, information, FCS, and flag. Let us understand these fields. Flag. It marks the start and end of the frame. It has a code as 0, 1, 1, 1, 1, 1, and 0. Address identifies the destination device. Control indicates the frame type, that is either information or superior or unnumbered frame. Information that carries the actual data. FCS, frame check sequence, used for error detection using CRC. HDLC uses bits of stuffing. Whenever 5 consecutive ones appear in the data, a 0 is inserted to prevent the confusion in flag pattern. The receiver automatically receives the stuffed bits when decoding. It also ensures reliability using acknowledgement. If the receiver detects an error using the CFCs, it sends a NAC and sender retransmits the frame. Now let us know the stimulation working. When I send a ping, that is data pack, from PC0 to PC1, here is what happens. PC0 sends a packet to router 1. PC0 sends the packet to its default gateway, router 1. the IP address will be 10.0.1.1, and the router 1 encapsulates and transmits. Router 1 encapsulates the packet into HDLC frame and transmit it through the serial link to router 2. This uses a DCE clock rate for synchronous bit transmission. Router 2 processes and forward. Router 2 receives the frame, moves the HDLC header and trailer, checks the FCS, and then forwards the IP packet to IP1. PC1 sends reply. PC1 sends a reply back following the same path. In this simulation, you can see green lines moving through the network. This represents packet traveling successful. If you observe a red line or a wrong packet, that usually means SDLC did not receive an acknowledgement in time, or there is a brief synchronization delay, but HDLC retransmits automatically, so the packets return green. That's why you see sometimes both red and green. It's HDLC performing real-time error handling. Now, let me see why packets turn red in depth. When packet reaches the correct destination but it turns red, it does not mean the route is wrong. It simply means the acknowledgement from the receiver did not come in time, or the DC or DTE clocks were slightly out of sync. The HDLC design is to retransmit until its acknowledgement. So the red packet means a temporary delay or frame transmission, not a routing error. Once timing stabilizes, you will notice all packets travel smoothly in green, meaning successful delivery. Key concept demonstrated in this visualization. Synchronous transmission. Data bits flow in sync with a shared clock. Framing. HDLC clearly defines frame boundaries using flag. Error detection. FCS or CRC ensures the data accuracy. Acknowledgement and flow control. Packets are tracked and transmitted if needed. Reliable communication. Even if an error occurs, HDLC recovers automatically. These are the key concepts that are demonstrated. Okay, before conclusion, let's see the stimulation in Cisco packet. Now let's see this stimulation. I'm adding a ping to device name PC0 and other one to PC1. Let's see the stimulation. It has been transferred clearly from PC0 to router 0. From there through a HDLC link to router 1. From there to PC1. See, the packet transfer is successful. This one. Now let's see the conclusion. To conclude, this HDLC protocol stimulation for synchronous serial communication demonstrates how data travels reliably across two routers using HDLC encapsulation. Through this stimulation, we can visualize, understand how HDLC manages framing, synchronization, error detection, bit stuffing, and acknowledgement to maintain smooth and error-free data transmission. This project helped me understand the working of data link layer in real-world WAN network and how important synchronization and encapsulation